So if we're going to find some of those rules, I think most of you guys have kind of figured out the process anyways when we did the slope field for the power rule, but we're trying to sort of invert the process. So if I wanted the general rule for taking the integral of x to some power r of dx, so here's my indefinite integral. If I wanted the antiderivative of that, then I would have to sort of reverse the process of the power rule. So I wrote down our power rule the way that we remember it. We had taken the derivative of x to the r power plus c, and then I end up taking r times x to the r minus 1. We subtract 1 from the exponent, plus 0 is the constant. So we ended up with r times x, r minus 1. However, just to adjust it for what we were doing just now, where we're reversing the process, because here we don't really have r minus 1, it says r. So what I did, so that when we take the derivative of it, all I did was just add 1 to the exponent so that I will end up with x to the r power. So look, if I'm adding 1 to the exponent here, I have to adjust for that in front of the coefficient so that when I multiply r plus 1 here with the coefficient here, I end up with a 1 in front. So in this particular case, I need to also multiply the coefficient by 1 over r plus 1. So when we take the derivative here, we end up multiplying r plus 1 times this coefficient, which is 1 over r plus 1, so that we end up with a coefficient of 1. And then we subtract 1 from the exponent, so r plus 1 minus 1 just gives me r. And the constant, when we take the derivative of the constant, it's going to be 0. So that actually just gave us a rule that ends up, when we take the derivative, we end up with just x to the r power. So that means this is going to be the antiderivative of x to the r. So in this particular case, it's going to be r plus 1 x to the r plus 1 plus c. So if I made an example, I would say, let's pick, I don't know, 5 maybe, dx. That would then be equal to, okay, well, r plus 1 is going to be 6. So I need to do 1 over 6, that's the coefficient, times x to the 6th plus c. And you can clean it up a little bit if you needed to. Moving on to the next page, I did a few more of those. Oh, let me make sure it's in the right spot here. If you just do a simple constant, if I just wanted to find the derivative of this constant right here, for example, it's kind of another piece of the power rule. So we kind of can backtrack a little bit, but I tried to make it a little simpler. The only way we end up with a constant here is if the function itself in the beginning was k times x when we take the derivative. So I have to backtrack from that. So anytime I see an indefinite integral of some constant, like 10 or whatever, let's write that down here just for fun, dx. Here, by the way, it's so important that the dx is there because that tells me what variable I should put. So in this case, it's going to be kx. In this case here, 10x. Oh, I forgot the constant, plus c. That is the most common mistake, by the way, on the AP exam, or one of the most common mistakes at the very least. So if I did something interesting like, I don't know, 2 dt, then this would be 2t plus c instead. So just to prove to you how important that is. I also threw in cosine. I could have picked sine. It doesn't really, text. It doesn't really matter which I've done. I'm just reversing through the process here of, I know that the derivative of cosine is going to be negative sine of x plus 0 here, which is equal to Oh, look, I forgot the negative here. Typo, sorry. But what I did in this case, I rewrote it so that we ended up with, when I take the derivative, because my end goal is to get positive sign at the end, not negative sign, and I should have retyped that. But in this particular case, I said, okay, well, if I took the derivative, instead of taking the derivative of cosine, I'm just going to say take the derivative of negative cosine plus c. So in this case, I end up with, well, I know it's the negative is already there. Taking the derivative of a negative makes the whole thing negative. And the derivative of cosine is negative sine of x plus, and then the derivative of the constant is 0. So that gives me a negative times a negative, which is a positive sign. So that means this is going to be negative cosine of x plus some constant c.